Okay, we are going to continue with factoring. But if you can see, these ones are going to be a little bit different. They have a leading coefficient or an A term that's greater than 1. So in example 1 through 4, they have 3, a 5, a 2, and an 8. Okay, so what we're going to do is work with these ones, and they're going to be just a little bit different than they were before. So you can't just start factoring right away. What we're going to do is we're going to do something with this leading coefficient in example 1 through 4. So the very first thing you're going to do is going to see if they have a greatest common factor. So do 3, 9, and 12 have a greatest common factor? Okay, hopefully you said yes. So yes, something can go into 3, 9, and 12, and that number is 3. So you're going to pull out the 3 from each one of these terms. So I'm going to pull out the 3 from 3x squared, pull out the 3 from 9x, and pull out the 3 from negative 12. So 3, and then you're going to start with what we have left. So I'm going to I pull out the 3, I'm left with x squared. I'm left with, or you can say divided by. 3 divided by 9 is going to be 3x, so plus 3x. I'm going to get that plus sign from right here, it's already a plus. Negative 12, and then divide it by 3, I'm going to get negative 4 still. Okay, it's going to equal 0. Now I'm going to factor what's in parentheses into two binomials. So I'm going to leave this 3 here, and now I'm going to go ahead and just binomial is going to equal 0. So really I have here, here, and there. Alright, so I'm going to start with x. So what two numbers are going to multiply to get to 4 and then add to 3? So I'm going to make my little table. So I have 1 times 4 and 2 times 2. And these are my only 2 that I have. So I have 1 times 4. And if I manipulate these signs, I can get a 3 to add to 3. So I know that 4 minus 1 is going to be 3. So those are going to be my two numbers. So I have a 1 and a 4. So if I already told you, so I have a positive 4. I'm going to subtract 1 or plus a negative 1. I'm going to get 3. Okay, so this is where I have this. So now I'm going to set all of them equal to 0. So 3 equal to 0, x minus 1 equal to 0, and x plus 4 equal to 0. So this should remind you of what we did before with factoring. So 3 equals 0. That's not a true statement. Okay, so let's just put a little x through that, or 3 is not equal to, a line through the equal sign. I'm going to add 1 to both sides to solve for x here. So x equals positive 1. I'm going to subtract 4 on both sides to solve for x here. I'm going to get x equals negative 4. So I can't count this as a 0 because it says it's not equal to 3. Or it's not equal, 3 is not equal to 0. So I can't use that. Just erase a little bit here. So my zeros, x, is really going to be 1 and negative 4. Okay, so those are going to be your zeros there. And if you put negative 4 and 1, that's completely fine too. Alright, example 2 is exactly like example 1. So what you're going to do is you're going to look for your greatest common factor. So you have a greatest common factor between 5, 20, and 60. So what is it? And hopefully you're saying to yourself, it's 5. So 5 can go into 5, 5 can go into 20, and 5 can go into 60. So I'm going to pull out my 5, and what's left? X squared minus 4x, and divided by 60 here, so 5 divided by 60, what's left? Negative 12. Okay, it's equal to 0. So now factor into two binomials. Okay, so I'm going to do 1 times 12, and I have 2 times 6, and 3 times 4. Okay, so now what ones are going to add to get to negative 4? If I manipulate 2 and 6, this is going to be the one that's going to be working for me. So start with x, and 2, and 6. Now figure out your signs. I need negative 4. So if I have a negative 6 and a positive 2, so negative 6 plus 2 is going to give me negative 4, and negative 6 times 2 is going to give me negative 12, so that one works. So again, break it up and set them equal to 0. So 5 equals 0, x plus 2 equals 0, and x minus 6 equals 0. 5 does not equal 0, so again, that moves the line through it. Subtract 2 on each side to solve for x, so x equals negative 2. I'm going to add 6 to each side here to solve for x, so x equals 6. So my 2's zeros that I have are going to be negative 2 and 6. Alright, let's see. Example 3, you're going to look for your greatest common factor. Greatest common factor between 2, 3, and 5. Okay, hopefully you're looking at these and saying to yourself that there is no greatest common factor, and actually these are all prime numbers, so there's no way to simplify this even further. So now we have to think about something else that we can do. And the second thing that we can do is going to be take the 2, or my leading coefficient, sorry about that. So take my 2, which is my A, and I'm gonna call it throw it to the back. So I'm gonna throw this 2 right to the back. Okay, so my 2 is going to now be factored into the problem, and it's going to be with my C. So I'm going to say, if I don't have a 2 right here, so this is kind of gone right now, I have an x squared plus 3x, and this is where I factor it in, so I have 2 times negative 5, which is negative 10, equals 0. Okay, so I'm going to factor again like in 2 binomials like I normally do. So what 2 numbers equal negative 10? So 1 times 10, 2 times 5. Now what set of these ones give you a positive 3 if you manipulate it? And if you think about 2 and 5, that will. So start with x. I'm going to use 2 and 5. So if I said 5 minus 2, it does give you 3. And 5 times negative 2 does give you 10. So positive 5, negative 2. All right. So this is where it gets a little bit tricky. This is when we already factored into the problem as 2, and so now we have to factor 2 out of the problem. Okay, so I'm going to factor out 2 by dividing this side, just the negative 2 by 2, and factor this side out by 2. So I'm going to divide everything by 2. So x and then negative 2 divided by 2 is negative 1. So I have x minus 1, equals 0. And x plus 5 halves, can't really reduce that any, so I'm going to leave that as 5 halves. If you can simplify that, simplify it. If you can't, you can't. So in this case, we can't. So it's going to be x plus 5 halves equals 0. Okay, so now I'm going to solve for x. Add 1. So x equals 1. And I'm going to subtract 5 halves on both sides and solve for x. So x equals negative 5 halves. So my zeros are going to be x, negative 5 halves, and 1. Alright, number 4. Again, I'm going to look for my greatest common factor between 8, 22, and 5. And you can see there is no greatest common factor. So I'm going to, again, throw it to the back. So pink pen here. So 8 gets to be thrown to the back. And again, I'm multiplying this. Okay, alright. So what's left is going to be x squared minus 22x. Now 8 times 5 is going to be plus 40 equals 0. 2 binomials. What 2 numbers equal 40? 1 times 40. 2 times 20. Okay, I have, let's see, 3, no, 4, yes, so 4 times 10, 5 times 8, okay, I think I'm going to stop there. Alright, now what one of these sets is going to give me 22? And this one will, okay, so I have, it starts with an x, and 2 and 20. Now I'm going to manipulate my signs. I need to get to 40, positive 40, and negative 22. I know that a negative times a negative equals a positive, so I also have to negative 2 minus 20 is going to give me negative 22, so these are both going to be negative signs. All right, because I factored 8 into my problem, I now have to factor 8 out of the problem. So divide by 8, divide by 8. All right, so I have a negative 2 divided by 8, which is negative 4. So x minus 4 equals 0. Oops, forgot to do that. And I have negative 20 over 8. And negative 20 over 8 doesn't factor completely, but you can reduce negative 20 over 8. All right, so negative 20 over 8, if you divide both sides by, let's see, if you divide them both by 4, negative 20 divided by 4 is going to be 5, and negative 20 divided by 4 is going to be 8. So here you're just going to divide by 4 here. So now I'm left with x minus 5 over 2 equals 0. So I'm just going to reduce right there. All right, so they're set to 0. Solve for x. So add 4 to this side. So x equals 4. Oh, no, I did it wrong. I'm sorry, you guys. Go back to this one. I wasn't thinking. It's super late. I am so sorry. All right, this one is right. So x, add 5 halves. Add 5 halves. So x equals 5 over 2. So this is 5 over 2 right there. Negative 2 over 8. Sorry, this is now x. You're reducing by 2, so divide by 2, and you get x minus 1 over 4 equals 0. Sorry. Add 1/4, add 1/4. I wonder how many people caught me on that one. All right, so now x equals positive 1/4. So those are your zeros. So x is 1/4 and 5 halves. All right, so those are all your example problems that you're going to do. So what you're going to do now is you're going to try. So the you try, I want you to go ahead and try the 1 through 4 down here, because they're going to be exactly like your examples up here. Okay, so I want you to go ahead and pause the video now and solve these for yourself, and then go ahead and check them when you get them, or when you get back in. So I'm going to keep solving them. You guys are going to pause them and then unpause me when you're ready. All right. Okay, so hopefully you have paused me and you've solved these on your own. So I'm just going to give you the answers, and then if you have questions on the you try 1 through 4 or any of the other ones that we're going to do in a second, I want you to ask me in class on Tuesday. So number 1, your zeros are going to be x, and then your brackets in negative 4, negative 1. Try to get those. Okay, so x and then bracket. Number 2 is negative 1 and 7. Number 3 is negative 5 and 2/3. And this one is going to be, 3/5 and 1. Again, if you are having questions on those ones, please ask me during class, but go back and try to find these. Always look for your greatest common factor. So I'm going to tell you right here. So the first thing you're going to do is look for the GCF. Okay, and then if you can't, if none, you're going to throw A, or your leading coefficient to the back. All right, so those are kind of your notes, just to make you kind of remember what you have to do on those ones. So again, try those ones and see what happens. And then let's just go to the back of that paper. And you're going to have this, so 5 through 12. Okay, so 5 through 12. I want you to try them all, but I'm going to ask you for certain ones during class. So go ahead and try them all, 5 through 12. Get your answers, and then I will ask you some of these. I'll ask certain people for some of these on class on Tuesday. So make sure you have these ones done, and then I will go ahead and post your homework as well as this video. So again, I gave you the answers to 1 through 4 up there, and then 5 through 12, I want you to go ahead and try. I will call on people to tell me how they did this in class on Tuesday. All right, you guys, there isn't any really note cards for you to do except for knowing how to factor, and so I won't do note cards, but I will post homework. All right, talk to you guys Tuesday.